Alrighty, so today we're going to be looking at instantaneous rate of change for functions. So we've been having a look through this sort of stuff up until now. In particular, trying to work out what is the gradient on a line, on the tangent of any line. So if I have some sort of function here, and I have a point here, the question is, hey, how can I work out what the slope of the tangent line is? Now, one way we did this was by approximating. So imagine I wanted to find the slope at A. Now A is located at -2. Well, I could do it by working out a secant, right? We've done this before. Now you can see this secant line looks like this and goes through the point A and the point A plus H. So H is just some difference. If I change H, I can make these 2 points closer or further apart. And what we can see is that if I put this really far away, it doesn't look anything like the tangent line, which you can see in blue here. But as I bring A smaller and smaller and smaller, this actually looks almost like the same line that we're looking for. And if we can work out the gradient of this bad one, well, if we get these ones really, really close together, we might actually find what the slope of the blue line, the actual tangent, the one we're looking for, is. This can give us a nice average. This is going to give us the exact answer if we can only make H small enough. So let's work this out from a picture. So imagine I've got 2 points along this curve. It doesn't matter anyway. I'm just going to call this function f of x. Don't have to worry about it. Alrighty, well, one is at the x-coordinate a and the other is at the x-coordinate a plus h. So it is h distance apart. Alrighty, so the question is, well, what is the slope of this line? Now, in this particular drawing, it'll look like 0, but I'm talking in general. Well, this point is a, comma, f of a, right? Because f of a is just the function, the y's coordinate. Similarly, we're going to have a plus h as the x-coordinate and f of a plus h. So this leads us to, if we want to find out the slope between these 2 points, we can just use our normal gradient function and we can go So we can have a look at m equals delta y over delta x. So the change in the y is going to be f a plus h minus f of a all over a plus h minus a. And we can see on the bottom we get f of a plus h minus f of a, no change on the top, but on the bottom the a's cancel out and we're just left with h. And so this tells us the slope of any particular secant that we are interested in. But what we're going to be looking at is what happens when we take the limit as h goes to 0 of this function, f of a plus h minus f of a. Alrighty? So we're going to be looking at what happens when h gets really, really small. And most of you will see the immediate problem if h approaches 0. Alrighty, we'll come to that in a bit, but let's just have a go at working out the numerator of this little function here. So, if we've got actual functions, let's work out f of x plus h, and then also work out the difference between f of x plus h and f of x. Alrighty, so if f of x is equal to that, well then, f of x plus h is going to be equal to 5x plus h minus 1, or 5x plus 5h minus 1. And that is as simple as we can get that. But then it wants us to work out the difference between f of that, x plus h, and f of x. So we're going to go f of x plus h minus f of x. Well, that's equal to 5x plus 5h minus 1 minus 5x minus 1. The 5x is going to cancel with the 5x. 5h is going to be left, and minus 1 minus minus 1 is going to be plus 1, so that cancels as well. So we're just left with fh. This is cancelling with that. This is cancelling with that. Alright, let's have a look at the second one. Slightly more interesting function. We've got a square in there. So if f of x is equal to x squared plus 5, well then f of x plus h is going to be equal to x plus h squared plus 5. Expand those brackets, we get x squared plus 2xh plus h squared plus 5. Alrighty, and now we're going to use that to work out f of x plus h minus f of x. And once again, the x squared is going to cancel with the minus x squared, the 5 is going to cancel with the minus 5, and we're left with 2xh plus h squared. Alrighty, so those are some quick examples like that. Let's bring the denominator and have a go. Alrighty, so if fx is equal to 3x squared at x equals 2, calculate the difference quotient. Alrighty, so we're going to first work out what f of x plus h is. Alrighty, expand the brackets first. Expand those brackets. Now let's work out the fraction. So for part A, we're going to have f of x plus h minus f of x all over h. Alrighty, all over h. So it's the same sort of thing we were doing before, but now all over h. The 3x squared is going to cancel with the 3x squared, and we're left with 6xh plus 3h squared all over h. Now, this is something that we haven't talked about, but you'll notice that I can factor out a h on the top. Right? Which is cool because I've got a h on the bottom. Now, I'm allowed to cancel this. However, I do need to be careful. I'm only allowed to cancel this if h is not equal to 0. Why? Because if h was equal to 0, well, guess what? We wouldn't be able to do that because we'd be dividing by 0. So this only works as long as h is not equal to 0. So I'm allowed to do that, and I'm left with just what was on the numerator, which is 6x plus 3h. Now, part B of the question asks us to determine the gradient of the tangent at that point. Well, now I just need to substitute x equals 2. So we've worked out what the function is, so let's sub in x equals 2. So our function has now become f of x plus h minus f of x all over h, which ended up being 6x plus h, 3h, substitute in 2, 6 times 2 plus 3h, 12 plus 3h. Now what we're going to do to get the derivative is we take that limit. Alrighty, so what does this go to? Well, as h goes to 0, we would get 3 times 0 plus 12. Well, that's equal to 12. Therefore, the gradient at x equals 2 would be 12. And we're all finished.